We made it to question 4, and this question is asking us to sketch the graph of a function f that satisfies the following properties, right? And these properties, we've got some limits, whether they're going to some value or they're going to infinity, whatever it might be. We want to create the sketch, okay? So let's start off. I'll make some xy coordinate plane that we're going to be able to go ahead and put our graph on. And I'm just going to go piece by piece, try and fit all this together. So first things first is, let's take a look at this limit. We see limit as we go 1 from the left side, and we're hoping that that's going to go to 1. So I'll just label a couple things here. At x is 1, we got a y value of 1. I'm hoping from the left side I come into this point, right? But I don't know what happens with the rest of the graph yet, so I'm not going to touch this, okay? I'm just going to kind of label it, think about what's happening here. As I go from the right side of 1, I want to go up to 3. So I'm going to need some height of 3 up here that I know I'm going to come into from this side. As I go to 2 from the left, it looks like I'm going to infinity, which we know that this then implies that there is a vertical asymptote at that point, right? So there's a vertical asymptote at x is 2. We'll go ahead and label that here with a change in color. We'll put our dashed line. I know that, again, from the left, I'm going to positive infinity, so it makes it seem that the graph is going to go upwards towards there. Remember, we need to come into this point. We need to also come into 3 here, and this side needs to go up. So our graph is starting to kind of take shape. Maybe it's this. I'm not going to solidify that just yet, but I'll get close. Maybe I solidify at least this part here, right? So I kind of go up, and I'll have 3. Make sure we kind of check this off. I've got an asymptote on the left side. So now let's look at this next one. So it says we're taking the limit as x goes to 3 of my function, and that's going to exist, but it does not equal the y value at 3. So if I were to go over here, x is 3, I know that I'm going to have a limit that's going to exist, but I am not going to have the y value be the same. So for example, maybe there's a hole, right? Because the limit has to exist, but the y value is not going to be there, right? That doesn't mean that I have to fill in the hole. I can just leave that out, but maybe I fill it in, right? So maybe I fill it in. We'll put the hole here, for example, okay? Now, what I notice is that there's nothing else telling me what happens from 2 from the left side, right? So there's no other kind of properties there that are telling me that. So maybe I just assume that they both go upwards to positive infinity, right? Maybe I clean this graph up a little bit. So I'll do something like this. This goes up. Note that I don't care what the height is at 3 either, so this could go heavier down. There's all these different versions of the graph I could draw, but I'm going to leave a hole there at 3. I'm going to push this up to positive infinity as I go 2 from the right. This would be taken care of, then this would be taken care of. Let's try the other ones. So as I go to positive infinity, I'm going to go towards a height of -2. Okay, well, as I go way over here, I need to push down to -2. So there is also going to be a asymptote, right? In this case, though, this asymptote is going to be a horizontal asymptote, right? And so as my function goes, I'll draw that. And here, remember, you can have any shape you want. So this could kind of go like this and like this, whatever you want to do. I just need the function to come down and reach -2 and plateau, right? So that looks pretty sufficient. That'll take care of this. Now, what about this left side, right? So I need to bring back these 3 and figure out everything. So I knew what was happening here and here. I also see that as I go towards negative infinity, so as I go way over here, I just want my graph to shoot upward to positive infinity. So let's make a graph here. So I remember at 3, at 1, right, as I go towards 1 from the left, from the right side, I'm going to 3. As I go towards 1 from the left side, I go to 1, and then I need to be over here as I go to negative infinity, going to positive. So maybe my graph kind of goes upward. It can come into this. And remember, maybe it's even a parabola. Who knows, right? I don't really care. But it could go something like this. That satisfies the positive infinity limit there. This is going to satisfy 1 from the left, going to 1. And then over here, this is satisfying 1 from the right. When I take that limit, I get 3. Now, I have to figure out what's happening here. Do I want these to be both holes? Do I want to fill it in somewhere? Again, you have the luxury of deciding what you want. So maybe you talk about these both being holes and then you give a y value of 2. Doesn't really matter, right? So that's why we talk about sketching. This should be, right, sketching the graph of a function. So of a function, this is not of the function, right? There's not one set function. I'm just making the graph of some function that would satisfy this. Okay. So this is a possible one. Hopefully that makes sense. If you have one that looks a little bit different, totally understandable. Just make sure that all of the properties apply. Okay. Perfect. There we go. Question 4.